Example 2. Using the fundamental theorem of calculus with the chain rule. So in this problem, we want to determine dy dx if y is equal to the integral from 1 to x squared cosine of t dt. Now the problem here is that in this problem, the upper limit is not just x, it's x squared. So what we need is that to be a variable of the single power. So what we're going to do is I'm going to show you how to implement the chain rule using the fundamental theorem of calculus. So our first goal is to get rid of the x squared. So what we don't like, let's get rid of. So I'm going to let u equal x squared. So then if I take the derivative of u, du dx is simply equal to 2x. Now we're going to keep that on the side and come back to it. So if we use our u substitution, we get that y is equal to the integral from 1 to u cosine of t dt. Now we're going to go ahead and take the derivative on both sides with respect to x. So I take d dx of both sides, and I get dy dx is equal to d dx, the integral from 1 to u, cosine of t dt. And so now we're going to take the derivative. So we get dy dx is equal to cosine of u times the derivative of u dx. The reason that we have to write this is because this dx down here is different than this. And this is where the chain rule comes in. So we get dy dx is equal to cosine of u times 2x. Again, this du dx comes from right here. And then we need to go back to our original variable because we want it in terms of x. So the derivative of y with respect to x is cosine of x squared times 2x. I'm going to now show you the shortcut that I like to do. So this is one way of doing the problem. Here's the second way. I have y is equal to the integral from 1 to x squared of cosine of t dt. So here we go. This is the way I like to do it. I have dy dx is equal to d dx, the integral from 1 to x squared, cosine of t dt. Using the fundamental theorem of calculus, I can write that this x squared is going to go inside here. So I get cosine of x squared times the derivative of the inside piece. Just like in before, the chain rule applies the same as derivatives, so you get this is 2x cosine x squared. For more complicated functions, it might be easier to use a u substitution, but generally for the fundamental theorem of calculus, just doing the chain rule on the side works just as well. So on your own right now, I want you to try this one, pause the video, give it a go, and then unpause it and see if you got it right. So here we go. Y is equal to the integral from 0 square root of x e to the power of t dt. So using the fundamental theorem of calculus, I'm going to take the derivative, and I get dy dx is equal to d dx 0 square root of x e to the power of t dt. Dy dx is equal to e square root of x times the derivative of the square root of x. So dy dx is equal to e to the power of square root of x divided by 2 square root of x. If you're confused about where they want the square root of 2 square root of x came from, that's from taking the derivative of the square root of x.